life situations that we see every day. Let's start.
A solution is mixture where one substance is dissolved in another, so that the properties are the same throughout. The substance that dissolved is called the solute, and the one that is dissolving is the solvent. For example, when you dissolve sugar in water, the water is the solvent, and the sugar is the solute.
Water is called the universal solvent because it can dissolve many substances. This happens because water is a polar molecule, meaning it has positive and negative side that helps pull solute particles apart.
Together, we make a solution.
Solutions can be dilute if there's only a little solute, or concentrated if there's a lot. How much solute can dissolve depends on solubility.
If a solution still has room to dissolve more solutes, it is called unsaturated. If it cannot dissolve any more solute at a given temperature, it is called saturated.
See, temperature also matters. Hot water dissolves juice powder faster than cold water.
Now, let's talk about acids. Acids usually taste sour like lemon and vinegar. But remember, don't taste random acids. Some are dangerous like hydrochloric acids.
Acids release hydrogen ions H+ in water. They are also detected with indicators like litmus paper. Strong acids like hydrochloric acid can burn skin or corrode metal, while weak acids like citric acid in oranges are safer.
Bases usually taste bitter and feel slippery like soap. Bases release hydroxide ions in water, also called hydroxyl ions. That's why soap is great for cleaning. We also use indicators to determine if a solution is an acid or a basis.
The pH scale measures how acidic or basic a solution is. A pH below 7 means acidic. A pH above 7 means it's basic. And a pH 7 is neutral, like pure water.
Substances can also form precipitates in some reactions, which are solid particles that appear in the solutions.
Another property of acids and bases is that they are electrolytes. They can conduct electricity when dissolved in water.
We can test pH using litmus paper, pH paper, or even natural indicators like red cabbage juice.
The vinegar changes to a pink or less bright red color. The water being neutral takes the color of the indicator and becomes purple. the baking soda and water solution turns a bluish-green shade.
Acids and bases are everywhere. Stomach acid help us digest food, while bases like antacids help reduce excess acid.
In cleaning, bases like bleach and soap are used, while acids like vinegar are used for removing rust or stains.
Even in food, acids give sour flavors, like citric acid in lemonade, while bases like baking soda make bread rise.
When an acid reacts with a base, they neutralize each other and form salt and water. This process is called neutralization. That's how antacids work in our stomach, like this.
When you swallow food, it travels through a tube called the esophagus. The esophagus leads into the stomach through a hole in a sheet of muscle called the diaphragm. There's a round muscle at the bottom of the esophagus that works like a valve. The muscle relaxes when you swallow, allowing food to pass into the stomach. Certain cells in your stomach, called proton pumps, release acid to help digest the food.
Reflux doesn't usually cause any harm. But if acid splashes up into the esophagus over and over again for years, the esophagus can be damaged. There are several reasons this might happen. It's not uncommon for the valve to become weaker, so it doesn't close tightly. That allows acid and partially digested food to come up into the esophagus. Sometimes the diaphragm weakens around the esophagus, allowing the hole to become larger. This hole is called the hiatus.
So now you know solutions, acids, bases, and the pH scales are not just in textbooks.
They're in our daily life.